Section 7.2 is on solving exponential equations and inequalities. An exponential equation is an equation in which the exponents are variables. Here's what it looks like. If b to the x equals b to the y, then x equals y. In other words, if the bases are the same, then the exponents are equal. Let's take a look at a couple examples here. First I have number 1, 4 raised to the power of 2x minus 1 equals 64. So in order to set up an equation that I can solve with x, I want to rewrite each of those terms, each side of the equal sign, with the same base. I always like to try to get it to be the smallest base possible. So 4 can be rewritten as 2 squared, and that's raised to the power of 2x minus 1, and 64 is 2 to the 6th. So this is going to be multiplying here. This is going to be 2 to the 4x minus 2 equals 2 to the 6th. And now that my bases are the same, I can just pull off the exponents and set those equal to each other. So 4x minus 2 equals 6, 4x equals 8, or x equals 2. My second example is 1/2 raised to the power of 4x plus 1 equals 8 raised to the power of 2x plus 1. So remember that 1/2 is the same as 2 to the negative 1, and that's raised to the 4x plus 1 power. And 8 is 2 to the 3rd, raised to the 2x plus 1. Let's clean up and multiply and get rid of those parentheses. So that's going to give me 2 to the negative 4x minus 1 equals 2 to the 6x plus 3. And now that I have the same base, I can just pull off my exponents and make those equal to each other. So negative 4x minus 1 equals 6x plus 3. And we'll just solve from there. 10x is equal to negative 4, or x equals negative 2 over 5. Okay. Exponential inequality is an inequality in which the exponents are variable. So it's kind of the same idea. If b to the x is greater than b to the y, then x is greater than y. And you can also do that with less thans as well. So let's try a couple examples here. So 5 raised to the power of x plus 8 is, sorry about that. Okay. 5 raised to the power of x plus 8 is less than or equal to 625. I can rewrite, actually, I don't have to rewrite the left-hand side because I think my base is going to be 5. 625 is 5 to the 4th power, and now I can just pull off the exponents. X plus 8 is less than or equal to 4, or x is less than or equal to negative 4. Okay. Example number 2, 1/9 raised to the power of 3x plus 5 is greater than or equal to 1 over 243 raised to the power of x minus 6. In this case, I'm going to rewrite each of these with a base of 3. But let's do it in a couple steps here. So 1/9 is 9 to the negative 1 to the 3x plus 5 is less than or equal to 243 to the negative 1 raised to the x minus 6. And now I can rewrite 9 as 3 squared, and I can rewrite 243 as 3 to the 5th power. So this is going to be 3 squared, okay, this is getting a little complicated here, to the negative 1 to the 3x plus 5 is greater than or equal to 3 to the 5th, that's 243 to the negative 1 raised to the power of x minus 6. So that's going to give me 3 to the negative 2, multiplying those exponents to the 3x plus 5. You could probably, if you can do a couple of these steps in one, you can go ahead and do that, but I just wanted to take the opportunity to show you every little step here. Okay, so that's going to be 3, multiply again to the negative 6x minus 10, greater than or equal to 3 to the negative 5x plus 30. Now my bases are exactly the same, so I can pull off the exponents. Negative 6 minus 10 is greater than or equal to negative 5x plus 30. I'm not going to run out of room here. Or negative x is greater than or equal to 40. And dividing both sides by negative 1 and flipping my inequality, x is less than or equal to negative 40. So the main idea here is to get the bases the same, and then you can just set the pull off the exponents and either set them equal to each other or write it with the inequality symbol. Another use of exponents of an exponential equation is compound interest. And compound interest is interest that is earned on the principal as well as any previously earned interest. The principal is the amount that you've deposited into the bank, the kind of the starting amount. And on a regular basis, that money can earn interest. And then as that principal grows with the added interest, the interest is we call that compounding. The formula is A equals P times 1 plus R over N raised to the power of NT, where A is the amount after T number of years, P is the amount of the principal, R is the annual interest rate, written as a decimal, and N is the number of compounding periods per year. Okay, so let's take a look at an example here. Okay, find the account balance after 8